Yes, so yesterday we discussed about regression, we discussed about neural networks, we discussed about gradient descent, learning how we train our network. But yesterday the focus was mostly on regression. Today I will start with classification problem, and after explaining the theory I'll stop for some time to take questions from yesterday as well as today, because yesterday many people came after the class asking some questions. So I suggested them that they should ask these questions in the class so that everybody will be benefited, because those questions were very general. So today please ask questions, but after this session let me cover something so that we can do something new today. Okay, so let's start with some recap. What we discussed yesterday. It was okay. So let's start from very general problem. You have got some x, some y, scalar. Let's say your x is 0.1, y is 0.1, x is 0.6, y is 0.4, x is 2.7, y is minus 0.5, things like that, right? And I ask you, can you estimate y hat for any x? So this is my question, and you suggest, okay, I can have a function y hat as a function of x, which is, let's say, w0 plus w1x plus w2x square plus so on up to wd x to the power d, right? That's what we discussed. And then okay, how to find w's, how to estimate the w's. So you said, okay, since this is a linear function, I can use least square solution, I can use minimum norm solution, I can use gradient descent, right? To minimize the error. Okay, this is what we discussed. This was regression problem. What is regression? Regression means your output y hat is a continuous function. So it can take any value, any continuous value. Let's say here, if I am interested in values between, let's say, -1 to +1, it can take any value, any decimal value, -1, minus 0.999, minus 0.88, minus 0.78, like that. Any continuous value it can take. On the other hand, we have another kind of problems which are called classification problems, where the output is a discrete category, right? We discussed in the beginning. What was the example we discussed? For classification? Yes, lotuses and roses. To classify between the two. There the output was either rose or lotus. Right? Discrete classes, no decimal values, no continuous values. Right? So that was a classification problem. Okay, so today we will discuss about how to use neural networks for classification problems. So we'll use very similar approach. My x is, let us go back to our original example of rose and lotus. Let us take 3 flowers, rose, lotus and jasmine. Fine? Okay, I take my x0, x1. These are the width and height, right? Width and height. Okay, so what is my x0, x1? And then we have y. My x0 is 5, width is 5, and height is 2.5. It is a, do you remember the example? It is a rose, very good, R. So now my x is, my width is, let's say 2.5 or 2.6, height is 6. This will be a lotus. And when my width is 1.5, height is also, let's say 1.7, this is a jasmine, small flower. Jasmine is a small flower. So like that I can get many examples. Okay. So now if I want to estimate y, I have to convert it into numeric values, right? I cannot estimate strings. So easier is to estimate the numeric values. So let me call rose as 0, lotus as 1 and jasmine as 2. Right? I can write like this and so on and so forth. And then we discussed, tell me if we didn't discuss this, that we want to convert this into one-hot encoding. We discussed one-hot encoding, remember that? Why did we do that? But we can work with 0, 1, 2 also. Why did we go to one-hot encoding?
It is similar to probability that we can predict.
Yeah, but what is the need? We can, just like we did regression problem, we can also do classification problem. Just estimate 0, 1, 2. What is the problem there?
Categorical variables numerical variables.
We have already converted. No, y int is numerical variable now. 0, 1, 2. Why do we need one-hot encoding?
It is not similar if we represent 0, 1, 2. For example, if we are regressing a value 1.5, then it represents that it could be either 1 or 2, but in no case it could be 0. But there could be some cases which would be either 0 or 2, but in such kind of domain we cannot represent that.
Yes, very good. Very good explanation. So the reason is that this linear ordering is not there in our categories. Linear order is not there. For example, if something is 0 and something is 1, and in between, if my model is not sure, let's say something is 0, something is 2, if my model is not very sure, it will give an output 1, right? Which is close to 0 and close to 2, somewhere in the middle 1. If there is a linear ordering, like in our regression problem, it makes sense. But in categorical problems, it does not make sense. This will mean that if something looks somewhat like rose, and somewhat like jasmine, it must be a lotus. Is it true? No, it is not true, right? That is why linear ordering is not there. That is why we cannot use a linear scale to represent my outputs. That's why I use discrete axes. So why one hot? Right? So let me explain. So in linear ordering, if you put your rose, lotus and jasmine here, like 0, 1 and 2, then this means if something is somewhat like jasmine and somewhat like rose, then it must be a lotus. That is not true. But in our one hot encoding, we have got 3 axes, right? When it is, let's say these are 0, 0, 1 points. When this is my x0, y0, y1, y2. So when it is here, it is rose. When it is here, it is lotus, jasmine. You agree with this? Do you agree with this? So now if something is somewhat like rose and somewhat like jasmine, it will lie somewhere here, which means your value will be something 0.5, 0, 0.5. Right? So it is not necessarily a lotus. That is why we use one hot encoding. Fine? Okay. Now, what should be my error function? What should be my error function? Okay, I can say okay, let me go to next slide. I can say my y hat now I have 3 y hats like 0, 1, 2. Y hat is equal to, I can represent it like a neural network also, no problem. And then I have, let's say I have no hidden layer, just to make it simpler. And similarly here. Right? So I have my y0, y1, y2, this is x0. I call this as I0 layer, this is I1 layer. Right? You remember this notation from last time. Okay, now y hat I1 is equal to W I0 I1 X I0 summation over all I0 plus the bias. Correct? I can define my loss function or the error function as, okay, I can say that I can put a sigmoid also. Okay, if you remember, I can put a sigmoid here. Right? You remember this? What is sigmoid function? Okay, so I can say my error is y I1, the actual value, minus the estimated value square, summation over all I1, right? And then summation over all the samples divided by the number of samples. Correct? I can take my error function as this, right? Is this a good way of learning my model? Is this a good way of learning my model? Will this work? First of all, will this work for classification problem? Will this work? Huh? Why?
Because in classification model, finally we are predicting probabilities that are between 0 and 1. And the error that we get in those probabilities is intuitively quite small, because actual values are between 0 and 1, so error is also between 0 and 1. Now we square the error, the magnitude of error is also minimized. So actually we are minimizing the error while calculating.
That's what we want to do, right? We want to minimize the error.
No sir, no, not in that way. We want to minimize the error when the error is actually minimized. When we square the error quantity. For example, if I had error of 0.9, I will get y1 minus y1 hat is equals to 0.9. I will square it. So it will become 0.18.
81.
Sorry, 81. So it got reduced. And if I have a very small error, then it might be possible that it diminishes. So how it is a good model?
That is fine, no?
If by this model I predicted 100% efficiency, then also on training set data actually I cannot get 100%.
No, that is not the reason. This is a valid model. This will work, but it might not work very good. This is a valid model. It will work, but the performance will not be very good. The reason is you are somewhere close to the answer, but let me clarify. So when you update your weights, okay, why this model is not the best. So the answer is, when you compute gradient descent, you compute tau E upon dou W I naught I1, right? So this will be what? What will this be? So if you compute summation over S twice of yi1 minus yi1 hat, okay, upon ns, and then minus, okay, let me call this as h, so it is sigma of right into something like this, right? Correct? So when you are training your model, you have this term. As you are going closer to zero error, this term is becoming smaller and smaller and smaller, right? That is why your gradients will be very small and your learning will become slower and slower. So you remember that your parabolic this is your error, which is proportional to y minus y hat whole square. So as your y minus y hat is reducing, you are going closer to zero, your slope is reducing significantly, right? This is the slope. This reduces so much. So that is why the learning becomes very slow and it becomes practically impossible to train it very well, right? So instead of this, what we can use is, let us consider this kind of a model. Okay, let me just copy some things from there. Okay, we have this, and we know that this is either it is 0, 0, 1 or 0, 1, 0 or 1, 0, 0, right? Either one of them is on. So how I can define y is, I can say my y I1 is equal to, okay, let's first write the hi1, which is, we have already written, summation of w I0 I1 x I0 plus bi1 summation over I0, right? This was my h. I don't change this, but my y, earlier it was sigma of hi1, but now I make it as a soft max, e to the power. Okay, let me not write it straight away. Let me write it like this. Right? Is this a good approach? Is this a good approach? Because you are directly taking the maximum value, and whichever is the maximum you make it 1. Means okay, I have to write it a little more precisely, that out of these 3 nodes, whichever is maximum you make it 1, and whichever is not maximum you make it 0. yi1 equal to 1 if hi1 is equal to maximum over all hi, and 0 otherwise. Right? So whichever has the maximum value, I make that 1, means y will be 1, otherwise will be 0. That makes sense? Should I give you an example? Let us say I found a value yi is 0.3, 0.2, 0.9. Then I will make this, so this is my hi1, sorry, and my yi1 will be 0, 0, 1. Does it make sense? Okay, if I do something like this, it is doing what I want it to do. But the problem is that my y is not differentiable now, right? To compute dou E upon dou W, I need a differentiable function, but this function is not differentiable, right? Can I make it differentiable now? So instead of taking a max, I will take a soft max. So to make it differentiable, I use soft max. Instead of max, I use soft max. So where yi1 is equal to exponential of hi1 this function, okay, just compute for this hi1 what will be my yi1. Just compute using this formula. Can you do that? Can you please do it on your notebooks or your Jupyter notebooks or your calculators, whatever you are comfortable with? For given hi1, can you compute yi1 using this formulation? The hi1 is given to you 0.3, 0.2, 0.9. Can you please compute yi1 using a soft max now? What do you get? Could you please do it? Anybody got the answer? Anybody got the answer?
0.268.
Okay, somebody else? Anybody else got the answer? So fill this table. Should I do it with you? Should I do